Hello, and welcome all to the inaugural episode of the Diverseco Podcast, a series devoted to all things measurement and automation. I'm your host, Nicholas Talley, the marketing manager here at Diverseco, and I am pleased to be joined today by one of our esteemed subject matter experts, Peter Hern, to talk about the wonderful world of collaborative robotics. Peter, welcome, and thanks for taking the time to talk to our audience today about this exciting area of automation in cobots.
Well, thanks very much for that, Nick. Really appreciate the opportunity to speak to you about cobots and what they can do for our customers.
Absolutely. And before we get stuck into it, Peter, would you mind telling us a little bit about yourself and your journey into this world?
Sure. I've been involved with industrial automation for, I guess, the best part of 20 years. I sort of started with companies like Rockwell Automation and then some time with ABB. Specifically with cobots, though, it's probably been about 5 years now I've been involved with collaborative robots. Collaborative robots are a relatively new concept in the world of automation, starting around about the 2008 to 2010 mark with a company called Universal Robots, and it was actually Universal Robots that I started with my journey in terms of collaborative robots. In the last 3 years, I've been with Diverseco with the Doosan range of collaborative robots, and so yes, I've had a reasonably broad range of experience in terms of automating processes within the manufacturing sector, everything from food and beverages through to general manufacturing, contract manufacturing. So yeah, it's been a really good journey.
Sounds good. Well, we're lucky to have you here, Peter. The first thing I'd like to speak about, and so for those of you unaware, Peter, as collaborative robots or cobots, like you had mentioned, are still a relatively new concept. Could you please explain to our audience what exactly they are?
Sure. Okay. Well, I guess that it's they can be variously described as the worker's best friend, but also as the boss's best friend. Essentially, workers love the fact that the dull, dirty, and dangerous tasks can be done by a cobot, while the bosses love the fact that the cobot keeps coming in day after day, doesn't take breaks, doesn't take holidays, doesn't call in sick, and can work overtime without any extra cost. So in the bottom line is a collaborative robot is very much the same as an industrial robot, except that it has safety built into it. So it's been designed to collaborate with the workers. In other words, work next to the workers rather than being hidden away in cages and safety fences, which most people might be familiar with industrial robots. So it is the worker's mate and it is the boss's mate because it keeps on showing up every day.
Yeah, okay. So you mentioned that it's both advantageous to the worker and the boss. For the worker, why is that the case?
There's a lot of tasks that are performed within the manufacturing process, which a human is absolutely required because a human has two eyes and two hands, and there's certain tasks that you need a certain dexterity, and that's what a human can bring to the manufacturing process. On the other side of things, there's quite a number of repetitive tasks which don't necessarily need that dexterity. And those sort of dull, boring tasks can easily be handled by a collaborative robot. And that means that instead of people finding these jobs that are perhaps low paying and very boring and not inspiring, they can be placed into other positions within the operation that add more value to the business and let the cobot do those boring tasks of picking and packing, palletizing, maybe welding, those sort of functions that it doesn't necessarily require a high level of skill, but it does require repetitive action and accurate action. And that's where the collaborative robot comes into it. And so it takes away those tasks from menial tasks, if you like, from the workers themselves.
Right. So in that collaborative environment, is it safe to say that these cobots are going to have to be human sized?
Yeah, not necessarily, but often it is the case that they're nominally, we start off with a unit that it has a reach of 900 millimeters. So that's perhaps a little bit more, about the same as a human's reach. Doesn't have the dexterity of a human, of course, although we're getting better and better at that with all the time with different end effectors, we call them, the hands, if you like, that go on the end of a robot. But yeah, that's about the size. So it doesn't take up a lot of space, and that's one of the great things from the boss's perspective. He doesn't have to take up a whole lot of real estate, precious real estate, in his factory to install this level of automation.
So on the notion of not occupying a lot of real estate, and given that these robots operate collaboratively with human workers, what does that collaboration look like, or what can that collaboration look like?
Okay, you could picture a line where a human is required to do some level of intricate assembly that requires the manipulation of an eye coordination, hand-eye coordination, to put a part together. But once that part has been put together or packaged in a particular way, it then needs to be placed into a box, for example, or that box then at the end of the line needs to be placed onto a pallet. That doesn't necessarily need the same level of hand-eye coordination, and it's just a very repetitive task. And that's where the robot, or the cobot, can be placed directly next to a worker, and safely operate, in most cases, right next to that human operator, and get those processes done, such as putting a part into a box, taking that box and putting it onto a pallet. Those are the sort of processes, those highly repetitive processes that humans don't really like to do, those sort of processes, but the cobot is happy to do it day in, day out.
Right. So you've described this automation space, or this manufacturing or processing space whereby collaboration between robot and human is enabled through cobots.
Correct.
Historically, that hasn't been achievable, has it? With prior to collaborative robotics, the only option really had for automation at scale was industrial robots. What
Mhm.
what are the differences, besides collaboration, I guess,
Mhm.
between cobots and industrial robots, and why do cobots now even exist?
Sure. One of the challenges with the industrial robot, one of the good things, let's perhaps, there's a number of variances or differences between the industrial robot versus the collaborative robot. And so the key elements would be, for example, speed, payload, safety, space required, time to deploy, and also flexibility in deployment. So in the first instance, we have to recognize that industrial robots have the advantage of being able to operate at faster speeds and at higher payloads than cobots. And so for large scale manufacturing, heavy duty manufacturing, they're ideal. However, when you come to looking at the small and medium size operator businesses, SMEs, a lot of them are not at the scale of their operation that can justify the cost, the real estate, and the infrastructure that's required for an industrial robot. And that's where the collaborative robot really comes into its own. It's actually aimed at the smaller processes, the smaller flow throughs, the less speed and the lower payloads of these smaller operators. So, for example, we have collaborative robots that can operate, let's say, for example, up to 20 kilogram payloads, 25 kilogram payloads, and operate, say, for example, packing boxes at a rate of maybe 8 to 10 a minute, or palletizing at 6 or 7 boxes a minute. Now, clearly, an industrial robot can go much faster, but there's a whole lot more interaction, infrastructure that's required within a factory, and a whole lot more real estate that's required within a factory to install those industrial robots. The other element, of course, is flexibility. The collaborative robot runs from 240-volt power, just a GPO plug-in, and maybe some compressed air for a gripper, for example. But it also can be very easily moved around a factory, especially if you're a contract manufacturer. This morning you wish to be doing this particular process. Maybe it's picking and packing, but this afternoon you need it to be doing palletizing. With a collaborative robot, you can very easily move it from one process to another as the requirement moves within your factory, as compared to an industrial robot, which once it's fixed in place, you're not going to be moving that in the next 5 years, probably. So that's another advantage for the smaller manufacturers, is the flexibility. And that's probably where the big difference comes in the real estate, the flexibility, and the speed of deployment. Safety, of course, is the big thing. The reason that industrial robots are able to move faster and have higher payload is because the whole area is fenced off to keep the humans away from it. And that's probably the main difference. An industrial robot is a separate environment of operation, whereas a collaborative robot, as its name says, a cobot, it's collaborating with the humans. There's no separation. There doesn't need to be necessarily separation between the humans and this piece of machinery. And that's the probably the key difference.
Right. Yeah, that's fascinating. So, as you've just said, one of the primary differentiating factors, hence the name of collaborative robots, is that they can work collaboratively with humans within the same work environment. Whereas, like you've just said, industrial robotics, I mean, you would classify that as a separate work environment. Now,
Absolutely, yes.
and I think for some, the thought of working alongside a robot is a daunting one. I think that might be fair to say. They're large, they're heavy, and seem like collaboration with one would be unsafe. Could you speak to the concept of safety with cobots that you kind of branching off of what you had were touching on towards the end there?
Certainly, yes. That's one of the key elements that was an introduction of the collaborative robot, and the fact that it has the ability to work near and close to humans is the safety that's actually inbuilt into the robot itself. So it has a series of sensors throughout the robot or cobot, the joints, etc., and it's constantly sensing for any obstructions or collisions. And then the safety elements of it ensure that if it senses a collision with a human or any other obstruction, it will stop in a very rapid way that will ensure that it cannot cause or tries to avoid causing any harm to anyone that it might touch. And so there is actually an international standard that goes towards collaborative robots, and we have to meet those international standards of safety insofar as the stopping distance and the stopping time. That means, of course, that a collaborative robot cannot move as fast as an industrial robot. It's just a function of that safety element. And it's one of the differentiators, of course. We don't move quite as fast as an industrial robot. We don't have as high a payload necessarily as an industrial robot. But again, we don't have to have that separation because the safety elements built into the cobot arm will try its absolute best to protect people working around it. And we can easily and always do demonstrate that to our customers, just how safe it is for the operators to be able to work close to it. Of course, safety is a very important element, and whilst the arm itself is collaborative, we have to ensure that the application is also collaborative. In some cases, it's not the case that the whole application itself is collaborative. If, for example, you've got a piece of moving equipment like a drill or a polisher on the end of your cobot arm, that application's probably not collaborative. Because that moving element, that rotating element on the end of the arm may have the potential to injure an operator if they get too close. So we do have to look at the overall application to ensure that the application is collaborative rather than just relying on the arm itself.
So you mentioned that there are a series of sensors on each of the joints. So what would a collision look like with each of these joints? Is there a difference? And of course, when I say collision, I'm not talking high speed collision. I mean, what does a
Mhm.
collision look like with each of these joints, and how sensitive are these
Okay.
sensors?
Well, that's one of the elements of the international standards. The joint, we can actually program the sensitivity of the joints to determine the potential force or inertia that is imparted in the situation of making contact with an obstacle or a human. And so that's number one. We can set the sensitivity, and it's actually utilizing force torque sensors within each of the joints. And so it's constantly monitoring the force and the torque of those joints. And if it sees a spike of a certain amount over and above the normal operating parameters, it will then immediately stop. Now, in terms of immediately stopping, what that would mean, if it was to hit your arm, for example, and there was some resistance there, it's likely to move by around about 1 to 2 inches maximum, and often less than, I should be talking metric, shouldn't I? 25 millimeters it might move before it actually physically stops. It feels like if it hits you on your arm, it probably feels like a little bit of a light hit, but not a hard hit. It doesn't cause bruising or anything like that. You know that you've had some contact, but it's not the sort of contact that's going to cause any harm or injury to humans. So that's the sort of level of safety that it can impart.
So with customizing the sensitivity, like you were mentioning, is there a potential to create, for lack of a better word, safety zones where you know within the reach of the arm there exists like a safer zone depending on the application, which I guess maybe for an application, maybe maybe there's a requirement for going quickly around something, whereas
Mhm.
once that arm backs off and it starts to occupy a wider reach, you want to slow it down so that it becomes safer. Is there potential for customizing these sort of safety zones?
Oh, absolutely. Yes. There's multiple zones that can be set within the collaborative robot for different applications. And just as you mentioned, there is normal speed and reduced speed. And what we would do is, for example, you can either set it at a particular area where it's well away from any potential human interaction, it can go faster. And when it's coming closer to potential human interaction, it goes slower. So therefore, the safety and the sensitivity is increased. Um, the other way we can do it is the use of area scanners, such that if a human comes close to the area, it will automatically go into reduced speed, or it can in fact stop. So we look at the application. We do it as part of our operation and planning and project management. We look at the risk assessment for each application, for each project, and determine the level of safety that's required based on the speed and movement that's required, and the customer's requirements as well. Each customer has their own specific requests in terms of safety requirements. But yes, we would go through that process, identify potential areas of risk, and apply the various technologies that are available to us to ensure that one way or another, the humans are going to be safe around this piece of equipment.
They certainly sound quite safe, or at least the potential is there to make them as safe as you need them or as safe as you want them to be. So that's very reassuring, I guess.
Sure.
So we know, that cobots are occupying a unique use case space, given that they can work collaboratively alongside humans for a variety of tasks and safely, it would seem.
Mhm.
But what are these tasks? What applications are cobots ideal for, and what exactly, like end of arm tooling and the grippers, enable these applications?
That's a very good point, because at the end of the day, the cobot itself is just an arm, and it can't do anything by itself. It can move around, but it doesn't actually do anything until you put something on the end of it. And that's why we call them end effectors or end of arm tooling. Uh, the grippers and various tools that are available are very wide. Everything from a simple 2-finger or 3-finger mechanism to grip parts. It might be vacuum cups on the end of the arm to vacuum hold boxes or a part or a bag, for example, to pick it up, to place it. There's quite a variety of different tools that are available. One of our suppliers has even got the things like screwdrivers as an end of arm tooling, polishing heads for polishing parts and bodies, car bodies, for example, even sanding applications. There's a whole myriad of various tools that are available to make the cobot not just an arm, but a functioning piece of manufacturing equipment. And of course, one of the key elements that we do at Diverseco is welding process. So we've worked with one of our suppliers to develop a package that includes a 350 amp welding unit. And with the collaborative robot, we can very quickly, or our customers can very quickly develop repeating tasks for welding parts, which takes away a very boring, dull task for operators. But more importantly, it produces a very high quality, repeatable product for them. So the applications that you can do with the collaborative robot is really limited to your imagination or what the needs are of the customer. Keeping in mind, of course, that the normal processes are highly repeatable and perhaps don't need the high level of dexterity that a human would do. So it's not there to replace humans. Humans have still have a very big demand in manufacturing, but it's some of those processes that the cobot can do, more of the tasks that are just, as I say, repeatable. So yeah, the end of arm tooling can be bespoke and designed specifically for the type of application. But I guess that the typical areas would be pick and place. In other words, pick up a part and place it in a box or into the next assembly process, for example. It could be an assembly process such as screw driving. It could be a finishing process such as welding or sanding or polishing. It could be palletizing at the end of a line when all the parts are put into a box or product is put into a box. That box needs to be put onto a pallet for shipping. Well, the cobot can be picking up that box and placing it onto the pallet in the correct pattern. So those are the sort of processes that we typically are seeing as the ideal application for collaborative robots.
Yeah, so you had mentioned in there that these cobots really, in each of these applications, they're not really designed to replace humans. You know,
Oh no,
they're
definitely
they're
not.
yeah, they're collaborative. They're designed to augment the processes that humans are currently performing. Is that fair to say?
That's exactly right. It's an augmentation of the process. Um, you've got to keep in mind that most of the processes that humans do can be fully automated with the use of special purpose machinery and all those sort of things. But the cost of implementation of those special purpose machinery is limited to the really big manufacturers that can afford to spend, $1 million or $2 million on these special purpose machinery. For most of our customers that are in the small and medium sized businesses, they can't justify the cost of these very specialized pieces of equipment. And so the human element is by far the better way to go. However, if we can allow those humans to be doing the value part of the process and let collaborative robots, which are a much lower cost for implementation, do the repetitive, boring tasks, then at the end of the day, it adds a real lot of value to the owner of the business.
Yes, that was that benefit to the owners and the managers that you were alluding to
Correct.
earlier.
Mm-hmm.
We've kind of come full circle with that. One of the interesting things that you had mentioned before was that the tooling is what I guess coupled with the payload and the reach of the cobot itself The tooling is what enables the application. And you had mentioned one of our suppliers on Robot who have a whole range of sort of plug and play end effectors that can do exactly that. They're going to enable that application. What about unique applications? We have conversations semi regularly about people who have weird and wacky applications that they would like to test the feasibility of using cobots for. Can we create custom grippers that are sort of outside of the scope of some of our suppliers? How unique can we get there?
Yes, absolutely. We're fortunate within Diverseco that we've got the skill sets, the people on board who have a lot of many years of robot application, and they know the various ways to create really quite unique types of gripping mechanisms and etc. manipulators to do various jobs. And so having those sort of people within our own team, the designers, the engineers, etc., we're able to design a process that is not off the shelf. It's totally bespoke to the particular application that you require. And that's everything from picking up very fine items to picking up very heavy items and manipulating them in a way that you can't necessarily do with an off-the-shelf type gripping mechanism. And yeah, we're very pleased to be able to have that capability in-house to be able to offer that process for our customers for their applications. And so we obviously we need to look at what the customer needs are. What's the end result? And the most importantly, this is all about, from a customer's perspective, what can it do for me? How can it help my business? And we have to look at that and say, okay, the best way we can help you is to get to your end result is to do this, this, and this. And that may require a bespoke design of gripper or some other part of the process. It might be, for example, it might be a lifting mechanism or a traverse track. All of these things are available, seventh axes, to make the whole process more versatile and more value to at the end of the day for the customer.
Yes, that seventh axis is particularly interesting because I know for palletizing operations, I mean, if you're stacking a large pallet, if you're looking at a cobot with a reach of, what is it, 1.9 meters, let's say, or
1.7, yeah.
1.7, that's probably not enough to stack a pallet to its, to 2 meters, 2.2 meters high, is it? So with that seventh axis, that really it enables even more applications, and as time goes on, there's becoming more and more of these additions to cobots that are just allowing them to do so much more.
Absolutely, yes. The one of the advantages of the seventh axis, the lifting mechanism from On Robot, is number one, it is fully collaborative, so that's a good safety element. But yes, it does allow us to stack, or our customers to stack pallets up to 2.2 meters. Now, if you're familiar with customers are familiar with container transport, the typical height for a high container inside is 2.2 meters. But often, if there's an automatic palletizing unit that only palletizes to maybe 1.4 or 1.6 meters, then there's a lot of headspace within that container that is being paid for but is not being used. So if the products that are being palletized are going into a container for shipment, whether it be across Australia or across the world, you want to maximize your volume uptake within that container. And having the ability to utilize a collaborative robot to palletize to a full 2.2 meters is a real game changer. Typically, you would have to have gone to an industrial robot to be able to get the reach to be able to do that 2.2 meters. Now we're able to do it with a collaborative robot, which makes it more accessible to the small and medium enterprises. And with the situation in Australia now, where there's a lot more production coming back to Australia, reshoring of manufacturing in Australia, it means that our manufacturers are shipping their products all over Australia and potentially all over the world. And that does mean that there's a whole lot more containerized product being moved around. So let's maximize the value of that container volume and stack our pallets to the maximum height. That's where the cobot with the lifter comes into its own.
Yeah, it's fascinating. That really is fascinating. The applications that cobots are ideal for paint, a very specific picture for where companies will find benefit in their utilization. Outside of these specific applications that we were mentioning, which seem to just continuously grow by the week at this point, what are the general benefits of automating with cobots? Why should companies consider automating with cobots in the first place? You mentioned the flexibility in deployment. But I
Mhm.
imagine there's quite a bit more. Am I right, Peter?
Oh, sure, absolutely. It's about keeping the production going when there's potentially lack of staff. And we're all aware that we certainly have a lack of of staff in Australia at the moment. People are crying out, whether it be for welders or for general manufacturing staff. There is definitely a shortage of staff, and so that's where a cobot can come and do some of the heavy lifting or the monotonous, boring tasks that you just can't get a person to do on a continuous basis. And so that's where it really does come into its own. Even things like machine tending. As I say, there's a lot more manufacturing coming back to Australia. So that could be CNC machining of parts. Now, rather than having a person standing at a machine waiting for it to finish a part, then take it out, put a new one in, that a cobot could be doing that process. And not only doing it for 8 hours a day, that can be doing it for 24 hours a day. Just load up magazines with your raw material, and the cobot can, and lights out, can stand there all day, all night, and feed the machine and take out the finished parts and stack it away. And that's where the benefits really do come into it. It's a game changer for a lot of small and medium manufacturers to be able to increase their productivity, increase the quality of the finished product, and get the products that they manufacture to their customers in a good time.
Right. So you had mentioned, I think, at the beginning of the podcast that cobots are such a great addition to the operations of small to medium manufacturers because of a variety of I guess barriers to entry that are removed with cobots. The flexibility of deployment, which is to say, you can use it for more than one application. The footprint that's being occupied, the ability for it to be collaborative. What are there any others that really speak to the benefit of a cobot?
One of the other things is actually the total deployment in the first instance, or multiple applications, of course. Um, a lot of manufacturers of industrial robots at this point in time, as a function of the supply chain issues, whether it be computer chips, etc., they're struggling to get industrial robots. We are hearing from some manufacturers of 6 to 12 month delays. If they place an order today, they're not going to see that industrial robot for 6 to 12 months. Now, if somebody wants to spend some money today, they want to be able to get a result sooner rather than later, get that return on investment. One of the advantages with collaborative robots, certainly with our supplier Doosan, is that we can get actual supply very quickly. Besides the stock that we keep ourselves, we know that we can get supply from Doosan very quickly. What that means for our customers is that we can put a project together, an application together, and have it actually deployed within their facility in the range of maybe 8 weeks, maybe 10 weeks, depends on the application. And that sort of turnaround is just unheard of when it comes to an industrial robotic application. So the benefit starts to flow to the manufacturer so much quicker. So that speed of deployment is a key element for the customer. Absolutely.
Yeah, yeah, I assumed as such. What about the ease of programmability? Are these cobots easy to program? I've had the joy of seeing, programming in action. Well, I don't know that it could be classified as programming because it's really suited for, for the layman, for people who aren't fluent engineers or who aren't engineers at all. Is that right?
Absolutely. That's one of the great things about collaborative robots. You don't need to have a degree in mechatronics or robotics or coding to be able to write a program for a collaborative robot. It means that our customers can have one of their own staff do the programming. It really is that simple. With a one-day training program that we offer, we can teach our customers how to program the robot to do quite complex tasks in a very simple way. It's really the teach pendant that we have that has a very good interface, a very intuitive, logical interface that allows a customer to see what they're doing, move the robot arm very easily, and put it into position, set the positions that it needs, that they want it to do, set different functions, whether it be open a gripper or close a gripper, etc. So in terms of programming, a customer can set a new program, develop a new program themselves in a matter of half an hour. They can actually have a new process in place. And then that process is saved and can be recalled at any time that they need to come back to do that same job. And that's really one of the big differences. Compare that to an industrial robot, for example, and we really, most customers don't have that skill within their own team to be able to write the code that's required. That means you're going to either employ somebody or call our technicians out, and it can take time. Whereas customers with a cobot, they can program it themselves and have that process operating very, very quickly.
And that programming requires no coding whatsoever, does it?
You can code if you want to, but it's not required. No, it's really is very intuitive, point and click type applications. So it doesn't need any coding requirements at all. It's just very simple process that anybody can be taught very quickly. That's the part that really impresses me. When I first got into collaborative robots, I was so amazed at how quickly you could program it compared to writing code. And I'm not a code writer, but I could see the benefits immediately with cobots.
I imagine that probably removes a bit of the barrier to entry as well, or a bit of the hesitancy that, maybe manufacturers who don't have that team of engineers, or at least a team of engineers that have used cobot or have any cobot or robotics experience. I imagine that makes that conversation a little easier, wouldn't it?
Certainly, yes, yes. Especially when, as a part of the process that we always go through with our project installations is a training program for the customers' operators. We show them the setup that we're doing in the first place, but certainly train them on how to set their own programs, how to write their own, to program the cobot to do different functions. It's really vital that the customer feels, and the operators as well, not just the owner of the business, but the operators we believe they need to feel that this is a part of them. It's a workmate for them, and they need to have the confidence to be able to program it and not fear it. And that's the beauty of a collaborative robot. You don't have to fear it. And that it's part of that process of debunking the fear of robotics, that we show the operator how they can easily program it themselves. And that immediately empowers the operator to start looking for other applications as well. And often one installation at a particular facility leads to many other applications once the operators see, hey, boss, can we get another cobot to do that application? Or how about that application? Nobody wants to do that job. Why can't we get a cobot to do that? And that's the sort of flow-on effect that we often see with our customers.
Is it such that you can have, because we had mentioned earlier in the podcast that the end of arm tooling is really that thing that enables the application. If you had two end of arm tools, could you have two end of arm tools at the end of on the end of a robot with like some sort of mechanism that quickly changes them depending on, maybe there's a really unique application that requires one gripper, and then in that same operating area it would benefit from having another gripper, to save you from having, two cobots, for instance?
Certainly, yes. With the on-robot end-of-arm tooling system that they have, you can actually fit two tools to the end of the arm. And so, for example, if you were doing a machine tending application, for example, one tool could be set to put the raw material, to grip the raw material, to place it into a machine center, and the other end of the side of the tooling can be set to take out the finished part. And so in a single movement inside the machine tool, we can take the finished part and also place the raw material to do the next process. Overall, it speeds up the overall process for the machining center, which improves productivity. So yes, that's one way to do it. Secondly, is because the cobot is easily redeployed to other applications, you also need to be able to change the tooling very quickly. And with the on-robot quick changing mechanism, we can very quickly change from, for example, a finger style gripper to a vacuum gripper with just a simple click-clack. Take off one tool, click in the next tool. The robot will automatically sense that it's a different tool there and set the programming accordingly. So from a redeployment perspective within an operation, it's a very, very simple process. And that's another big benefit of the collaborative robot. It's easy to move around, easy to set up in a new process, easy to change the tools to suit the specific application that you need to do right now. And that's great.
That sounds great. So you can have two different tools on the same on the same arm,
Yes.
essentially. You can have one day where the cobot is doing surface finishing or
Mhm.
some sort of assembly process, and then the next day you can have it doing something else. Is that right?
Absolutely, absolutely, completely different processes. So, as you say, a sanding disc on doing some sanding today, and then tomorrow it's got a screwdriver attachment on that's doing an assembly process, or it puts you put a vacuum gripper on it and it's doing a pick and place function. So yes, it's highly adaptable, and that's the benefit as compared to, say, for example, a special purpose machinery or an industrial robot. It's typically set to do one specific process. Does it very well, but it's only going to do that one job. A cobot is closer to being a human. In other words, the human can actually do multiple functions, do one job today and do a different job tomorrow. Likewise, the cobot can be the same process. It'll do one job today, it'll do a different job tomorrow, and it's very easy to set up and get operational in a matter of minutes.
Fascinating. Truly fascinating. Yeah, that's all been very insightful. Thank you, Peter, for enlightening both myself. I'm constantly learning, so this is very much appreciated, and our audience on so many of these aspects of collaborative robotics. It's been great talking with you. Really, thank you for your time.
Not a problem at all, Nick. It's been a pleasure. This is my job. It's to talk about collaborative robots, and of course all of our listeners out there. Of course, Diverseco is, as I said before, mentioned before, we are a full turnkey automation company insofar as robotics goes. We can provide all the engineering resources, manufacturing resources to put these processes together, as I say, whether it be a welding, robotic welding, cobot welding, palletizing system for end of line, pick and pack. We're not just the supplier of the basic equipment. We actually do full projects in conjunction with our customers. So yeah, we're here to assist and ensure that customers get the best value for their investment.
Well said, Peter. Well, thank you all for joining us today for this episode of the Diverseco Podcast. If you'd like to learn more about what we discussed today, feel free to reach out to us. We'd love to hear from you.